Pew pew! Pew pew pew! Lasers. Lasers are exciting, and that's why I'm particularly excited for today's video, because I finally got my hands on my very own proper laser cutter in the form of this Makeblock Laserbox Pro. And in today's video, I'm gonna basically be sharing my entire experience with this laser thus far, and I've been using it pretty thoroughly over the last few weeks. If you're familiar with this channel, you know my tool of choice is generally the 3D printer. And I definitely still think 3D printers are the ultimate singular tool when it comes to rapid prototyping and democratizing design. There's pretty much nothing like 3D printing in the sense that you can create just about any 3D shape you want. With that said, I have been pretty eager to get my hands on a laser cutter like this, because while laser cutters are generally limited to flat items, you have a lot more versatility when it comes to the materials you can cut and engrave with them, and that's something I have certainly been testing for the past few weeks. Now, I have played around with a few laser engravers on this channel. Here's the first one I ever got, this Super Carver. It's now discontinued, and it's got this little 500 milliwatt laser. It was nice for burning images onto paper cards and wooden dice and crackers, but unless you had a very specific need that this thing could handle, it was more or less a toy and a bit of a novelty. The Laserbox Pro here, on the other hand, uses a 40 watt CO2 laser. So that's 40,000 milliwatts, or nearly 100 times stronger than this thing right here. Also, while this laser puts out UV light, which is nice for burning things, the CO2 laser blasts materials with infrared light, which has some pretty cool properties, such as being able to cut and engrave transparent materials, and it's also just really powerful. So yes, Makeblock sent me their Laserbox Pro a couple months ago, and since then I've been testing it out on all sorts of different materials and whatever ideas I could come up with. And for today's video, I'm basically gonna try to share my whole journey, all the ups and downs. I've certainly had some problems with this machine, but ultimately it's also helped me produce some really cool things. So I'm excited to put it all out there for you. I'll start out with some general information, and then we'll kind of just start looking through all the different projects I've done and learning more about the machine as we do that. As I've said, I consider this my first proper laser cutter because it's quite different from these engravers I've been using in the past. And because of that, I think my experience should be pretty valuable for others out there who haven't had their own laser cutter yet and are just trying to get into it. But, you know, if you're familiar with lasers as well, I hope I can still make a valuable video and tell you about what this specific machine can do. So with that said, let's get right into it. Cool. Great, so before we jump into all of these projects, let me tell you a little bit about this Makeblock Laserbox Pro. So, first thing everyone always wants to know is the price tag. This machine is gonna set you back between $4,000 and $5,000 US, which seems pretty high compared to a lot of the 3D printers I review on this channel, but it's a pretty competitive price in terms of this market of prosumer desktop smart laser cutters. The Glowforge is probably the most popular desktop laser of this sort, especially if you're subjected to Instagram ads. So throughout the video, I'll probably compare this machine to the Glowforge quite a bit, since that's the one a lot of people know about, and quite frankly, this machine looks and operates quite similarly. So yeah, for this price, you're getting a prosumer device, which is basically a machine that's trying to fill the gap between potentially unsafe, kind of finicky kit lasers that you can get, and then there's also industrial lasers, which can be upwards of $10,000. So that's what this is. It's marketed towards educational spaces like schools, as well as maker spaces and small businesses. So if you're trying to run your own little Etsy shop, this might be a good tool, as long as it does what you need. Some of the standout features of this machine are the fact that, for one thing, you can run it offline. A lot of people complain about the fact that Glowforge machines must be connected to the internet and they run through a cloud software. The Laserbox Pro has its own software, which you can run offline, and while there are some limitations to that software, and it's kind of a bummer that you're forced to use it, Generally, it'll do everything you need it to, at least with a few workarounds, which we'll probably see throughout the video as well. Another great thing about this machine is it has a ton of safety features. On top of having all the relevant safety certifications, for one thing, you can't open the lid without the laser automatically shutting off. There's also a smart air purifier that connects to this machine, which pulls out the air from the laser chamber, runs it through a big chunky HEPA filter to deal with potential odors and harmful particulates. On top of that, the Laserbox software also gives regular reminders to clean things, as well as letting you know when you need to change your filter. There's also built-in liquid cooling, which should help preserve the life of that laser tube. It's expected to run for 8,000 to 10,000 hours. And we've also got air assist with a built-in air compressor that blows air out of the nozzle to help get cleaner cuts and generally reduce the chances of things going up in flames. Again, we'll discuss more features as we run through all of my projects, but let's take a look at what setting up this machine looks like. My delivery arrived as 3 separate boxes. Inside this first cardboard box, we have another cardboard box filled with cardboard. I'm not joking. Makeblock provides these cardboard sheets pre-cut and with this barcode that helps the Laserbox software instantly recognize the material so that you don't have to input thickness or settings. Everything's already saved in there. So that makes this really easy for first timers to just make something right away. They also provide these 3mm basswood sheets, a kind of soft plywood with this masking tape already applied to the top surface for a cleaner cut. Our next package contains that smart smoke purifier that is included with this Pro version of the Laserbox. Here's that big HEPA filter I mentioned, and we've also got the necessary cables and hoses to connect it to the laser cutter. Then there's this final plywood crate, which I suspect holds the laser cutter itself. So I will expertly pry that open. Expertly. And there isn't a whole lot of padding around this box, but everything does appear intact, and it is quite a beauty. It's also quite heavy, so I got an extra pair of hands to help me get this onto my workbench, where it takes up most of the space. The machine's footprint is 958 by 528 millimeters, and the air purifier will take up another 260 by 528 millimeters. In my case, I made space for the purifier under the workbench so I can easily toss the exhaust hose under the garage door when cutting to vent out that filtered laser air. Pew pew pew. Assembly is just a matter of connecting some hoses and plugs, so this machine is essentially ready to go out of the box. Lifting up that rather satisfying pneumatic lid, we find some more cables and the instruction manual, and removing this foam reveals our cutting area. Although, right off the bat, I noticed something was off with the honeycomb tray. Just look at that skewed edge. That can't be right. And removing the lower tray, it's also clear that this machine has already seen some use. Fixing the honeycomb tray was just a matter of unscrewing 2 stoppers at the front, and then I was able to force the tray back into its intended rectangular shape. So not a huge deal. However, the next thing I found was this little shard of plastic that looks suspiciously similar to the plastic that makes up much of this machine. I couldn't figure out exactly where this piece broke off from, so I just had to cross my fingers and hope it wasn't anything too important. I reached out to my contact at Makeblock about these strange issues, and that's when they revealed that this machine has already been used for other reviews. So that's something they didn't make clear to me when they sent me this machine. But at the same time, it's a free laser, so I can't complain too much. That said, it does make it harder for me to judge this machine with those weird things that were going on, because I don't know how much of it was from the last reviewer versus how well this would have looked straight from the factory. Anyways, I installed the Laserbox software on my MacBook and tried to connect to the Laserbox via Wi-Fi, but I learned that you need to first connect by USB or Ethernet cable for the Wi-Fi connection to work. That's when I realized my package was missing the male-to-male USB cable, and somehow I didn't have one lying around. So I was forced to install and run the software on this old Dell laptop I used to run my CNC, just so I could connect via the Ethernet cable. That connected successfully, and I was immediately alerted of a firmware update, so I took a few minutes to install that, and then it was time to start cutting. My first project was a custom skin for my game controller, which started with a test cut on paper. When we close the lid, the Laserbox camera scans for a material code, but since this isn't one of the official Laserbox materials, we'll just have to input our settings manually. I'll set the material height to 0.4 millimeters for this paper and import the DXF file I've already designed for my controller. Since we have this live camera view, it's super easy to drag my vector image over the magazine cover here and visualize my cut. And of course, I thought it was reasonable to set the speed and power straight to 100% just to see what this laser can do. 2 more clicks and the job gets sent to the Laserbox, where it's just a matter of bopping the big button, and off it goes. For whatever reason, I didn't film my first cut, but here's the result of 40 seconds of cutting, and to me, it's nearly flawless, with just a few burn marks on the back. That test gave me the confidence to move on to my final material, which is this paper-backed bamboo veneer. I'll stick some masking tape on the surface to reduce scorch marks around the cuts and shut the lid. If we're planning to use the same material often, we might want to add a material preset in the Laserbox software. That lets us save the material height, power, speed, and number of passes for both the cut and engrave functions. Once again, we're going full speed, full power, and we'll send that task over to the laser. Here you can see that top speed in action. The Laserbox software uses a so-called smart path planning algorithm to automatically determine the order of the cuts. And while it does travel back and forth more than necessary at times, it does at least cut out the outer border last, which is ideal to prevent the piece from moving. Again, the laser cut clean through my material. Now I can remove the masking tape, eventually. And here's the result. There are still a few spots that got scorched, so I guess I could have used lower power settings, but for me this is totally acceptable, so I'll hit the back with some spray adhesive and carefully align it onto my controller. There we have it, a pretty sleek and totally unique game controller. With such a successful first project, I was eager to laser anything safely laserable. From this 16mm thick polyethylene foam to 1/4 inch acrylic in one pass. I even managed to get a somewhat clean result with this dichroic PET film, and that's a pretty cool material I've been wanting to use. This is probably a good time to mention that you want to be very careful about the materials you burn here, because you are disintegrating materials, which releases particulates into the air. I was able to find several nice lists online from makerspaces of their laser approved materials, and I generally went off of those. And then for other materials, you can look up the material safety data sheet to make sure they're safe to cut, because some things can produce really harmful gases, such as PVC or anything that contains vinyl, so no cutting vinyl records, as cool as that seems. Never cut anything that you're not sure of what the material is, and if you're not sure that it's safe to cut under the laser. I've actually organized the rest of my projects in this video by material, so let's start with these basswood sheets that came with the Laserbox. I'll set the sheet in the top left corner of the machine, and when I close the lid, the software identifies the material in a few seconds with that special barcode. Now I can bring in my DXF file, set the units to match what I exported from Adobe Illustrator, and as you can see, all of our cut settings are already set. I'll just bump up the power a bit for good measure and send it off. Just over 8 minutes to cut this somewhat intricate design. You can see that the smoke is pulled towards the back of the machine and through that air purifier pretty effectively. There is still that distinct smell of laser cut wood in the air, but it's greatly reduced. My second layer for this piece didn't cut through quite as well. I figured the lens could use a bit of cleaning, so I hit it with the bulb duster. Lenses love the bulb duster. Anyways, as punishment, I had to sand through the back of this piece until the parts broke free, and it took way longer than I hoped. I hate sanding. After finally getting the parts free, I had to peel off the masking tape, which is kind of tricky with a piece like this. Not as satisfying as it should be. Actually, I'm going to be painting these pieces anyways, so for the next cut, I decided to remove the tape ahead of time. At least now we can compare the pieces cut without tape versus with tape. It definitely makes a difference. Alright, time to paint. After 2 coats of filler primer, I started painting my pieces using the indoor paint left over from my giant numbers project, and I quickly realized how terrible a brush was for painting these thin parts. So I threw together a quick paint booth and went for the air spray gun instead. While there's more cleanup, it's far easier to apply the paint, and the coats are way more even. It's pretty fun too. After the paint dried, I used a bunch of tiny dabs of wood glue to stack the layers and stick them together. I followed that up with a few coats of glossy polyurethane spray for some protection, and here's the final piece. I'm super happy with this one. And when the power settings are correct, the Laserbox absolutely does its job. Of course, this piece could also be 3D printed, which I did. And while the actual printing takes much longer, there's almost no post-processing here, so there's definitely a trade-off, but I guess it comes down to the material choice. There is another technique I wanted to try with these basswood sheets. It involves doing a low power cut that cuts through the masking tape, but not far through the wood itself, to basically create a stencil with the tape. It didn't look like the first pass even cut through the tape, so I ran a second pass, but I guess the piece moved a bit because the cuts weren't aligned. So things got kind of messy, but I decided to push forward since this one's really just an experiment. So I peeled away the tape in the areas that I wanted to paint and left it where I wanted to keep the wood bare. Then I got a nice big brush and dabbled on this bright red paint, just covering the whole piece like a happy little crime scene. Once the paint was dry, enough, I peeled away the remaining tape to reveal the basswood. Those edges could definitely be cleaner. I think my accidental double cut and the cheapish masking tape both contributed to that. But there's another trick. I'm actually going to put the piece back under the laser, hopefully in the same position, and run an engraving pass to create a third color. That actually helped clean up some of the edges as well, and I could also cut out the border in the same operation. Here's the result after the polyurethane clear coat. Again, my execution could use some work for this one, but I definitely see the promise with this technique. Next up, I decided to try out Makeblock's unique Bring Sketch to Life feature. All I have to do is draw directly onto this basswood sheet, and anything drawn in black marker should be engraved, while the red lines will be cut. I don't even have to connect to a computer. I just place my drawing, close the lid, and bop that button. The Laserbox takes a few moments to identify the material and process the drawing, and then it starts cutting. This first attempt was looking pretty decent, but some things were quite off. For one thing, I guess I placed the sheet too high, so the camera missed this top part of my drawing and clipped it off. The red line is also double cut, so perhaps I have to use a thinner or more red marker. Removing the tape, we can see a few small details missing and some lines blurring together. The bottom of this cut, though, is clearly warped, and I suspected that the camera might need calibration. So I found the calibration tool within the Laserbox software, which had me place a sheet of paper on the work area, and the laser cut this small grid in the center. However, that calibration just failed every time. With this grid down, the warping is very clear in the software preview, so I guess it was just too far off for the calibration to work. So I reached out to customer support once more, and they quickly responded with instructions for a more thorough calibration. This one requires you to cover the entire tray with a flat sheet of paper, and I had to run this Windows-only Chinese software. I also had to find the laser cutter's IP address through my router settings, and I eventually got it to cut this large calibration grid. Only to be met with another error. Troubleshooting led me to install Microsoft Visual C++ on the laptop, and after burning another grid with an even flatter sheet of paper, the calibration succeeded. At least, that means success, right? So that process was obviously a hassle, but I will say my next sketch was traced much more accurately. My red marker was totally running out of ink though, so I'll take the blame for this failed outline. However, once again, the cut didn't go completely through the right side, so I ended up cutting it all out on my jigsaw, and that kind of defeats the ease of this feature. I will say, once it's set up properly with all the correct settings, this would make a really fun activity at a tech fair for kids or something, but I personally don't have much use for it. Beyond those basswood sheets, I was also able to engrave and cut through this 5mm plywood. More surprisingly, I was even able to cut through this 12mm thick piece of pine in a single pass at 100% power and 3% speed. That's already much deeper than I expected to cut wood with this machine, and at 1% speed, I was nearly able to cut through this 16mm piece. With 2 passes, it should be no problem. Next up, here's my attempt to engrave a grayscale image onto that pine. The wood grain looks super cool, but most of the detail is lost here. By the way, this artwork is from an 18th century hypothesis of the universe. I thought that was pretty cool. I had the same issue capturing detail, trying to engrave a photograph as well, and I suspect it would take a lot of tuning to get multiple values of color from engraved wood. So strong black and white images tend to be more successful. That was my approach for this next project, which is this bamboo cutting board. Once again, I put tape on the surface to keep it clean, and this time-lapse really shows how scattered that path planning algorithm can be. This job took about 70 minutes, and I feel like we probably could have shaved off half of that time by engraving everything at once. That said, this engraving still came out super crisp and clean, so I finished it off with 2 coats of tung oil for longevity, and here it is, my suffering squid sushi platter. By the way, the working area of this laser is 500 by 300 millimeters, but it is possible to engrave larger pieces if you're willing to compromise just a little bit of safety. I was able to set up this larger piece for my aunt's Etsy shop by removing the bottom tray of the Laserbox and leaving one side sticking out the front. I enclosed what I could to get some of that safety back, and the engraving came out great. Another material I was really excited to try was leather. Here's a test cut I did with a relatively soft and thin leather, and that cut just barely made it through at 50% speed with full power, and at full speed and power, the engraving is nice and deep, but not really as clean as I hoped. I decided to try again, this time engraving at just 10% power and 20% speed, and that made all the difference. I also got a cleaner cut at 70% speed with 2 passes, so that goes to show maxing out the settings isn't always the best idea, and getting the best results requires some experimentation for any new material. Here I tried cutting a much tougher piece of leather, and this one got pretty burnt up before I could cut through. So leather does seem to test the limits of this 40-watt laser. However, I can still engrave thick leather, so I offered my rather busted but cherished belt to the laser gods to try engraving a reaction diffusion octopus texture. This cut did get interrupted by a software update, but I mostly managed to save it by combining 2 cutting jobs. So a few spots got lasered twice, but I'd still call this an upgrade. Now, anyone who's laser cut leather knows the unbearable smell it produces. I will say the air purifier makes a noticeable difference here. The smell is still present, but it's definitely much more manageable. Next up, let's engrave some mirrors. By cutting mirrors face down, you can laser away the reflective coating on the back, and that should look pretty cool. I made this 2-part artwork in Adobe Illustrator, with the front being 3D printed, while I'll laser cut the black lines. And by using vector line art like this, I can use the cut function so the laser actually follows the lines instead of going back and forth with that engrave function. First, I ran a small test with these little mirrors I got from my Disco Poly panels, and it's a good thing I did because, as it turns out, a full power cut is hot enough to crack the glass. 15% power with 2 passes worked much better, and with 30% power and 2 passes, I got exactly the 0.3 to 0.4 millimeter line thickness I was hoping for. With those successful tests, I was confident enough to cut my larger mirror. So I set it down on a piece of cardboard to protect the front, and I used this basswood piece to square it up with the machine. In the Laserbox software, I can now visually center my art over the mirror, and get this, if we click this link, the Laserbox will actually measure the material itself. That's right. This thing has more lasers. This feature worked fairly well for me too. As long as the material is opaque enough, it was accurate to plus or minus 0.2 millimeters, which is enough for successful lasering. The visual preview adjusts to compensate for the material height, so I'll have to recenter it, and then I'll put in those cut settings that tested well. It's a 5-minute cut, and just take a look at the result. Pretty cool. I 3D printed that front piece on my Anycubic i3 Mega X, and it came out super clean, though I didn't leave enough clearance with this first one, so I had to print another, and I gave it a thicker frame as well. These engravings look really cool lit from behind, though that can be a bit tricky to achieve without a deeper frame. Instead, I held it in place with this cardboard backing, and even that looks great. For another mirror, I traced this illustration from an old Japanese book of wave designs to turn it into another vector graphic. If it isn't clear already, experience with a vector graphic software like Illustrator or Inkscape will take your designs a lot further than just relying on the Laserbox software. The Laserbox handles these curves effortlessly. They look super sharp and clean. And I must say, using the engrave function also works surprisingly well here, leaving this grainy, frosted glass texture. I've also got these thick glass tiles, and I wondered if I could make a cool dimensional effect by engraving both sides. So I came up with these floating fish in Illustrator. I've got the 2 layers, and to prepare those for the laser, I just flipped the back cut horizontally, and I also made this rectangle, which I'll use to create a reference cut. I cut that out of basswood so I could align the glass tile using that bottom right corner, and then I used the same settings I did with the mirrors. More so than the mirrors, this glass seemed to break off in little tiny chunks, so the line came out with a more grainy finish, but it's also got a nice shimmer to it. I flipped that piece over and ran the second cut, dropped it into a 3D printed frame, and while the effect is subtle, I think it's another nice little piece. It was around this time that I realized the internet has a wealth of plotter tools that could work just as well for laser cutters. For example, cleversomeday.com has this extensive list of tools that generate SVG graphics, and I especially love the generative art tools. PlotterFun is a great one for converting photographs into vectors using a whole variety of artsy algorithms. Here I used the Stipples algorithm to make my cloudy photo look like an abstract shoreline. And by painting the back of the mirror after cutting, you can make these engravings just about any color. While cleaning up a bit, I found this screw. Curious. Anyways, the generative tool that I became most obsessed with was this awesome site called Flowlines by Max Sergei. This site can visualize crazy mathematical formulas to produce these epic flowing lines. It's everything I love, and even just cutting these into paper was so satisfying. All these lines cut through too, so it makes the paper bend in very interesting ways, and I think this could make for a really interesting deep dive. But paper wasn't enough, so I scanned my tablet computer and designed a pattern for that, since the Laserbox can apparently engrave anodized aluminum. Of course, I avoided cuts near any of the sensitive electronics, prayed that the visual alignment was accurate enough, and started engraving at 15% power. I figured I could just do another pass if the lines weren't deep enough, but this first pass actually looked really good. The alignment was off by about 2 millimeters, but the tablet survived, and it looks good. Afterwards, I found 3 more screws fallen on the tray. Then I noticed this piece of plastic on the lid, and the front fell off. Well, that piece wasn't covering too much anyways, so let's engrave my MacBook. This design had way more lines to it, and I really wanted to align it properly. So before engraving the laptop, I first cut the outline onto a sheet of paper to have this perfect reference. This way I could simply align my laptop right on top of this piece of paper and use that same position in the software. I also wanted to push the strength of the lines, so I upped the cutting strength to 50%, and it worked really well. It's interesting, in some lighting the lines are barely visible, but when it does catch the right light, it looks amazing. I wanted to do the same thing with my mom's laptop, but this older MacBook is just a hair too thick to fit under the laser. Luckily, there is a way to turn that 22 millimeters of vertical clearance into 52 millimeters, and that's by removing the honeycomb tray. Then I'll stack up a few sheets of basswood to bring the laptop back up into the laser's focal distance, and I'll use that paper technique again. The way I set this up was to import 2 DXF files that I created in Illustrator. There's the outline reference, and then there's the actual line art. I'll select everything and align it over the paper, and then I exported that in hopes of saving the location data. Spoiler, it didn't work. Auto measuring also didn't work in this case because the paper is technically below the lowest focal distance, but I'll just manually set that to 0. Then I'll delete everything except for the outline and run it as a low power cut. This out of focus cut actually made it blatantly clear that the right side of my machine is cutting way weaker, and I figured that I may have a laser alignment problem. But for now, I'm still gonna finish this cut. After all, it worked fine for the other laptop. So here's where I tried re-importing that artwork, but it was totally misaligned. So I tried what I normally do and just hit undo over and over, but this time it only got me 1 step short of recovering all the lines. So I just re-imported the lines and aligned it with the outline that way. But now the software wouldn't let me select those outlines. My solution was to move the flow lines 2 steps down, delete those outlines, and then move the flow lines back up 2 steps so they're still aligned. So that's the kind of annoying workaround I've had to use from time to time. In the end, I must have messed up somewhere because the cuts weren't perfectly aligned, but luckily, it still looks awesome. Alright, now we can deal with the laser alignment problem. To do this, I put masking tape over this hole on the left side of the laser head. That's where the laser enters the head before it's focused downwards. And by running a quick cut on the far right side of the machine, we can get an indication of where the laser is entering that hole. In this case, we can see that the hole is burnt on the very left side of that hole, while we want it to be centered as possible. To adjust that alignment, we need to unscrew this reflector on the left side of the machine, which is held in place by 4 Allen screws. Upon removing that, I found evidence that someone else had already glued down this tiny paper shim to push the beam to the right. Again, I can't know whether this was done in factory or by the last reviewer, but in any case, I'm just going to add another layer of masking tape on top of that shim to try centering the laser a bit further. So I screwed that back and repeated the burn test to find the dot closer to the right, but also shifted vertically. I added another tiny sliver of tape to adjust that horizontal axis a bit more, and for the vertical axis, it's just a matter of adjusting the angle while you're screwing that part down. So this test was nearly perfect on the horizontal, but too high. And after one more tiny adjustment, I actually managed to get a nearly perfect alignment. That deserves a tiny thumbs up. I also learned how to properly clean the lens and the 3 reflectors. This aspect is actually really well designed, with each piece held snugly in place with magnets. So I used a microfiber cloth and 91% isopropyl alcohol to clean up the glass on both sides. And this reflector has some real evidence of that misaligned laser, but it cleaned up quite nice. As did the other 2 reflectors on the left side of the machine here. With those fixes, our cuts should be cleaner than ever, so let's rock. And by that I mean, I want to laser a rock. So, using this small level and my hot glue gun, I fixed this rock to the cardboard base with a level top surface. Then I planned my artwork and started cutting. Even at 100% power, my first pass only left a faint impression on this rock. But I repeated that cut 4 more times, and thus my little cave drawing came to life. An ancient hunt of the buffalo. The results are really interesting. I think I may have melted this rock into glass. Fabrics also cut surprisingly well. I expected to be able to cut this denim, but engraved denim kind of blew my mind. I also tested this corduroy fabric, which worked just as well. Now, I'm not much of a tailor myself, but my partner Natalie is, so we teamed up to design this wild patchwork jacket based off of an old pattern she found in a German magazine. In Illustrator, I traced the panels, split them up, added seam allowance, and assembled all the parts for cutting. Then I cut sheets of corduroy to fit the laser bed, held them flat with magnets, and they cut out like an absolute breeze. Each panel takes about a minute to cut, and it's just so satisfyingly clean. The denim panels are upcycled from old dad jeans, and those scraps came in all sorts of shapes and sizes. So once again, that top-down camera was super helpful for lining up the cuts. I feel like the camera is calibrated better for thin materials because I was able to fix these oversized panels with very little margin for error. I literally cut hundreds of these little pieces of fabric in a day, so this laser cutter can really be a workhorse. Beyond that, it's up to Natalie to put these together.
Perfect.
Finally, it's time for acrylic. Almost certainly the best plastic for laser cutting. At 100% power and 7% speed, this 4mm acrylic cuts like butter. Natalie wanted some starburst earrings, so this is what we came up with. There are a few dents on the back surface from the laser bouncing off of the honeycomb tray. That's known as flashback, and a common solution is to raise the material off the bed. So I placed magnets under each corner of this sheet and more magnets on top to hold it into place. It's a nice dual purpose solution and it totally worked. This piece was flawless. Even the core of this tiny hole was preserved. That's crazy. So a few variations later, some jump rings and some hooks, and Natalie's got these groovy new earrings. Then we made these triple-decker statement piece earrings. And I also really like this sun and moon combo. That acrylic just cut so well that I had to design another version of my gazing eye. For this one, I used a mirrored acrylic as well as some awesome fluorescent acrylic that I've been saving since college. Only the top frosted layer had some problems with warping on the sides, so I redesigned that with a thicker border, and that took care of the problem. After peeling off the protective masks, I used these 4 metal standoffs to align and hold the 4 panels together. I think that's a more elegant solution than trying to glue them like I did with the wooden panels. Anyways, here's the final piece, and it might be my favorite version so far. The colors are stunning, and I love how the edges catch light to literally glow. It's another really cool piece. Okay, there's just one final test I had to try, and that is cutting these sheets of PLA I made from my failed 3D prints. I was worried that PLA might be too melty to cut well, but it actually worked. These are more brittle than acrylic, but I think they could still work for art and jewelry and such. But we'll save that exploration for another time. So that's where I'm at so far with this Makeblock Laserbox Pro. To do all of these projects, I've had the laser running for roughly 25 hours of actual cutting time, and in about 24 hours of cutting time, I was prompted to replace the HEPA filter, just to give you an idea of how often you need to do that. And Makeblock sells replacement filters at $160 for 3 replacements. It ain't pocket change, but relative to the price of the machine, it's reasonable. Plus, it's a great safety feature, so I think it's worth it. I definitely think a machine like this with all of the safety features and ease of use features built in would make a pretty awesome tool for a school or a makerspace or even a small business. Though if you do want to save money and you're willing to work on the machine a bit more, you might want to look into K40 style lasers, which can be 1/10 of the price for the same strength of laser. Of course, for a laser like that, it won't be packaged quite as nicely. You won't get all the smart features that come with the software. And like I've said over and over again, this top-down camera to me is just an invaluable tool for a laser cutter. Being able to actually see the material and where you're placing your design on that material is such an amazing feature that I don't think I'd ever want to operate a laser cutter that doesn't have that feature built in. Now that it's all tuned up, I think the accuracy of this machine is incredible. The linear rods and everything are very high quality in terms of the build of this machine. And I really think the software is one of the main things holding back what this machine can do. So hopefully Makeblock continues upgrading that software and fixing some of the little awkward things about it. Yes, the front fell off, but what can I say? I'm pretty excited about this machine and I can't wait to keep using it. As much as I experimented with, there's still a lot I still want to try. I know you can cut EVA foam, which sounds really fun and satisfying, as well as engraving rubber or engraving slate. That also sounds pretty cool. As always, I'd love to hear your thoughts as well. So if there's any other materials you'd like to see me cut or engrave, let me know in the comments. Or if you want me to explore any of these projects further or in more depth here on this channel, please let me know, because I'm just getting started with the laser. But that's gonna be it for today's video. I hope you enjoyed it, found it useful, and well, I'll see you in the next one. Till then, I'm Devin, this is Make Anything, and as always, stay inspired with lasers. Pew, pew, pew.